I'm John. I'm primarily a .NET developer. You might be able to tell from my accent, I'm from Minnesota. We're all here to learn about machine learning, and the first thing I learned on Friday night was that not everybody here is a software developer. And that might be a bit like saying, there are people who use Excel other than scripted through VBA. But machine learning has reached the point where libraries like TensorFlow allow non-developers to leverage machine learning, and that's great. So we have people using machine learning who aren't software developers, and you might be at a company that has a software team, and they're going to be using their language of choice, and in places I've worked, that's been .NET languages. So they're going to have huge amounts of IP and tools that work with your own data sets and whatever business objects you have, and you might want to leverage that, but you're not a .NET developer. So I'm going to talk about a couple of technologies for interoperating between .NET and Python. But if you're not interested in that particular combination, there probably exists something that does work for you. So I haven't got time to talk about how to do it, and there's tutorials online that can teach you that far better than I could. What I'm going to try and do is just demystify the relationship between .NET and Python. So by show of hands, who here uses Python? More or less everyone. It's the official language of machine learning. And what about .NET? Oh, quite a few. And who here is frequently mystified by the ecosystem of software languages? Yep. So we start with the CPU. Code that runs on there has to be written in the instruction set of the CPU, and we're going to use blue to represent that. And we'll have an idea of what it would mean for code to run directly on bare metal. Unless you're writing CUDA for GPUs, you probably don't do that. So you have to go through an operating system, which is the gatekeeper of the CPU. And this little key shape on the right represents the API of the operating system. And so any program we're going to run on here has to conform to that API. So let's suppose we have a Word document. We can't execute that because it's not code. So, unsurprisingly, we have a word processor, some kind of executable. It conforms to the operating system's API. It comes in instruction, uses an instruction set that matches the CPU, and this executes, and we can use this to view or edit our Word documents. And this executable perhaps was written in C++ and compiled into an executable. So we're told that Python's an interpreted language. And what that means is that we have a Python executable that can take Python scripts and execute them. But the executable here is Python and not helloworld.py. And we're told that .NET is a compiled language, which means that we write some code in C#, for example, and we compile that, and we get an executable, which drops into our CPU, like the other ones we've seen. But the reality is they're actually a lot more similar than the impression you'd get from that. So when you compile a .NET language, what you get is the common intermediate language. So this is the equivalent of Java bytecode. And this will not run natively. So what happens is when you compile your C#, it will compile the content of your code into a portable executable and generate you a kind of bootstrapper native Windows application. And the code in here is a very simple layer that just loads the .NET framework off your machine and uses that to host your IL. Now, Python, our interpreted language, the way Python works is actually to compile the Python first, and then execute that. So the two technologies, Python for .NET is a drop-in replacement for Python, but one that will load the .NET framework in the same way that any .NET application would, and that lets you use .NET libraries from Python. IronPython is primarily a .NET library. It ships with a thin wrapper, which loads the .NET framework. And what this gives you, the combination of all of this gives you something that is equivalent to a drop-in replacement for Python. But given that the Python interpreter is written in .NET, it doesn't have full support for all the Python libraries you might want. So where IronPython has benefits over Python for .NET is I can write an application in C# and reference IronPython and allow people to enter Python snippets into a .NET application. And that's, yep. So where this might be of use is, I think I'm out of time.